Yesterday I took a look at the decorator pattern, and we learned our new design principle as well. So, like, you must have uh, noticed this design pattern in solid principle as well. It is O of the solid principle, basically open close principle, which says that classes should be open should be open for extension but closed for modification. Right? So what does it mean? Classes should be open for extension means we whatever functionality we want, we can basically use that class to add that functionality. And close for modification means that it should not provide a way to basically change the core behavior of the class. So these two statements can look contradictory to each other, but these are actually not. So let's understand from an example, right? So let's say that I create a class, or let's say I create an abstract class, right? Abstract class. So let's create an abstract class, right? So let's say that the abstract class is car, for simpler example, right? So now the abstract class car, let's say that it has a abstract function abstract void speed. So the user can define the speed, right? And it has a private name function. Let's say private private string name, which I don't want the user to modify. So I will just return the name, or we can mark it as protected. Let's mark it as protected. Protected, right? So anyone who is like extending this class can implement it, but not the other way around, right? So here, like the car is open for extension. Uh, Basically, I can extend the class and make the changes, but I cannot directly modify the class, right? Let's for simplicity, let's make it not a class, normal class. Let's say that it's a normal class, right? My bad. It's a normal class. Okay, so now if I want, I can basically, what I can do is I can create a Hyundai Hyundai car that extends from this car, and only I will be able to like access the name method. A normal, if I try to implement it, then I will not like try to directly create an object of it, then I will not be able to use the name method. So this is kind of, I have extend the class is extendable in itself, but like it's not modifiable. Okay, so yeah, that was our that is our today's design principle. Let's move to our today's pattern, that is decorator pattern. Okay, so let's first understand the formal. Let's first write down the formal definition of what decorator pattern is. Then we will break down each word and try to understand what does it mean, right? So, what is a decorator pattern? It attaches additional responsibilities to an object dynamically. It provides a flexible alternative to subclassing for extending to subclassing for extending functionality. Extending functionality. Yeah. So what does this mean, right? So this is the formal definition. What does this mean? Let's understand word by word, right? So attaches additional responsibility, which means that if a class has some behavior via decorator, mm, we can either modify its behavior or maybe add some extra behavior to it. Ideally, we usually add some extra behavior to it, right? Uh, for example, if I have a, let's say, a coffee, a simple coffee I have, right, and it cost me, let's say, 50 rupees. Okay, then let's say I have mm, what we can add, let's say, chocolate simple coffee, right? So we added some chocolate to that coffee, simple coffee, and it became of, let's say, 60 rupees. Okay, so this chocolate is basically additional behavior of this coffee, right? So that's kind of a real world analogy of what additional responsibility means, and we will see in a moment that that's actually what a decorator is. Okay, attaches additional responsibility to an object dynamically. What do we mean by dynamically? So see, we have earlier what we have seen. We can create simple interfaces. We can create uh, other things, or we can extend some classes. But those are concrete. So if let's say I create a car class again, class car, right? Or maybe let's say not class car. Let's say an interface car. Okay. So I have some methods, right? Like speed, gear, etc. Now let's say that the company or whoever the person is responsible after the system is created, the car system is created, he comes in and says that okay, just add one more functionality to the car, that it could also have a color, right? The requirement comes in later at some later point of time. At that point, what happens is that each of the interface that is like extending the car is has to be changed to accommodate this new requirement. By dynamically, we mean that we will be able to add the color without changing the another class, right? Let's take an example of this simple coffee only. We have a coffee. Let's say we have a coffee. Okay, it's an in. Let's say it's an abstract class, or rather not say it coffee. Let's say it's a beverage because then coffee would again abstract beverage. Okay, so abstract class beverage. Okay, this okay, the syntax may be messed up, but don't let's avoid for that. Let's focus on the understanding. So that beverage class can, let's say, it says it says that it will have a milk, it will have a hazelnut, it will have, let's say, some other thing, chocolate. Okay, then let's say we have a coffee class, coffee, that extends this beverage. Okay, and it will inherit all these methods. Now let's say the company comes in, they say that okay, add one more thing, we are introducing a new type of what we say sub complementary or complementary elements. We are introducing, let's say, almond milk, right? So now if I add that almond to this abstract class, then my coffee would have to, my this coffee, or let's say if I have a tea, or if I have XYZ many beverages, those all have to like incorporate this element, and that would become a mess, right? So what we are gunning for here is, we are targeting that we don't have to like change the fundamental architecture of it, and we can basically dynamically, like once a requirement comes in, then we will be able to add that requirement directly, right? Just through the code, we will not be changing any fundamental classes, or we are not changing any already created things. We just have to add that dynamically. We will see in a moment how we are achieving it via decorator pattern, right? Right now you have understood what we are gunning for. It provides a flexible alternative. So flexible alternative because it's very dynamic, we can add it at the, like at the runtime, uh, not at the runtime, I mean easily. Okay, it provides a, for two subclassing, like the example I show you, the classes beverage, then their subclasses are coffee and all that. Two subclasses for extending functionality, right? So we extended the functionality, we are targeting to extend the functionality without like flexibly. We are not tied into the ecosystem, we are doing it flexibly. Okay, so in the last observer pattern, what we saw is, like in the first video, what we saw, we achieved the composition, like we add use the car factory class, sorry, car class, and we added dynamic functionality to it via composition. So it was a flexible to subclassing for extending functionality. Okay, okay. So let's look at an example here. Okay, through live coding. Let's okay, first let's understand what we are trying to create, right? What usually in code, it's not very easy to type out comments and all. So I'm telling you what we are like creating. So we are creating a flexible coffee, let's say management machine in which we can add supplementary supplementary call it supplementary or what, the things which we add in coffee. Okay, let's call it things only. Add things easily. So what we are try, and it will calculate the cost. Okay, so basically let's say that I order a coffee. So it will always be a coffee machine. We are not targeting a beverage, just the coffee. Okay, so like they will not sell tea. That's given. Okay, so let's say that we have a coffee. and it cost me, like the same example, right? It cost me, let's say, 50 rupees. Then let's say that I have a mocha coffee. It will cost me 60 rupees. Now this mocha will be cost of 10 rupees. Then let's say I have chocolate mocha coffee. That's cost me, let's say, 80 rupees. So coffee cost me 50, mocha cost me 10, and this cost me 20. Okay. So again, we can create multiple combinations here. Like chocolate can be doubled, mocha can be doubled. Obviously, coffee cannot be doubled. So, like the customer can say that they want a double chocolate, double mocha coffee. Okay, and our system needs to calculate the cost correctly at all times. Okay, so we have a base object coffee that is being like decorated via the things, or what, condiments. We decorated by condiments, coordinaments. Yeah, that's what we call it. Uh, right. So this is the kind of system we need to create. Okay, and decorator pattern will help us create such a system. Okay, so let's flexibly look what like what we want in terms of like easy understanding. So for example, we take let's take a almond mocha chocolate coffee. Okay, here we know that coffee cost, I will just write the cost here, 50. The chocolate will cost 20, the mocha will cost 10, and almond will, let's say, cost 10. Okay, so it would be of 90 rupees. Okay, and what we are gunning for, that we have a, let's say, outer layer. So you can understand decorator like a layers of onion. So we can unwrap each layer, but at the end of the day, each layer is an onion layer. Bad example, but yeah, I think some of you will get it. So this will be then almond layer. Okay, it will, let's say, a cost, it will of, let's say, 10 rupees. Then this one will be of mocha, it will cost 10 rupees. Then I have a chocolate that will cost 20 rupees, and then I have a coffee that will cost me base cost 50. Okay, so what our system will do, our almond will say, okay, let me ask my mocha how much it costs. Mocha will say, okay, let me ask chocolate how much it costs. And chocolate will say, like, okay, let me ask coffee how much it costs. Coffee will say, okay, I cost 50, and chocolate will say, okay, you cost 50, I cost 20, so we have 70 rupees. It will pass to hit there. It will say, okay, I am mocha, I cost 10, so it will pass on 80 here. And mocha will say to almond, I'll cost 80, and almond say, okay, you cost 80, I cost 10, so means the total cost would be 90. Okay, so this is how our like system will work. Each like each layer of onion will be our coordinates, right? Okay, let's dive directly into code. Is my screen visible? It's not. Okay, it should be visible now. Hmm. Hmm. Okay, so we will create a, let's say, a class coffee. Let's create an abstract class coffee. Okay, and it will contain abstract string get description abstract int cost, right? Then we will have another class which will not be an abstract but a class of, let's say, simple coffee that extends coffee. In description we will say return I am not I am a simple coffee. Okay, and simple coffee would cost us 50 rupees. Okay, then again I can have a class that's, let's say, espresso coffee, right? Extends coffee. It can again implement all these methods and return espresso coffee, and it will, let's say, cost so simple coffee has milk, it does not have milk, so it will cost 40, 30. Okay, now what is the requirement? We need coordinates, right? So we have coffee, we have, let's say, abstract class coordinates, coordinate source, the spelling of it. Condiment. Okay, condiment is the spelling. Hmm. So we will have condiment, and let's mark it as a decorator. Okay. It will also extend coffee. So we'll have a condiment here, will extend coffee, and let's say that I have, okay, so it will also extend coffee, and it will have a coffee object with it, right? And it will have a abstract string get description as well, because the condiment would add the description of their own, right? Okay, so why we did that? Why we like condiment is not exactly a coffee, right? A chocolate is not a coffee. So what we are trying to do here? So for a decorator to work, right? The outside world should see it as the base object. That's how I can wrap multiple responsibilities to it, right? Because if let's say if the outside world does not see it as a coffee, then we will never be able to wrap any of our or change any of its behavior without like extending it. The outside world will see the condiment as a coffee, because at the end of the day it will take some like it will take a coffee only, right? So it will become a coffee. So let me first implement uh, write a wrap condiment means a decorator, then you will get the concept better. So we have a class, let's say mocha, right, which will extends the condiment decorator. Now what will it do? Implement the methods. I will in its constructor take a coffee, take a coffee, right? So this dot coffee equal to coffee, right? And in the cost I would say whatever be the like whatever be the coffee dot cost. Hmm. Let me think for a moment. Okay, we will refactor it later, but let's say that we have coffee dot cost plus the mocha itself cost 10, right? So we will have this mocha condiment. Similarly, we can have a chocolate condiment which will cost us 20. Chocolate. And this is spelling of chocolate. CHOC. Chocolate, my word. It's chocolate. Choco. Again, the constructor will take a coffee. And in the description, okay, one thing I forgot. In the description, it will take whatever the description of the coffee is, and it will add mocha, right? And whatever the description of coffee is, chocolate. Okay, and chocolate will cost 20. Yeah, so like these are our all the base classes. Not the base, like we have a coffee, we have its decorator, okay, and we have all the methods we need. Now let's try to create a double chocolate, double mocha, simple coffee. Okay. Second. Okay, so what we have, we will have a coffee, a new simple coffee, right? Then we have, let's say, a mocha coffee. So again, coffee is equal to new mocha coffee, right? And it will, we can also have a, actually we can chain all of this, right? So what we needed to create, okay, we needed to create a almond mocha chocolate coffee. Almond, oh, we never created almond. Let's first create almond. Almond. And what was our almond price? It was 10. Hmm. Okay, so we can have, let's say, we will create our coffee now. Coffee, new almond, new mocha, new chocolate, new simple coffee. So we have almond, we had double mocha, almond mocha chocolate coffee, almond mocha, we didn't have this. Almond mocha chocolate coffee. So we have this, right? Now let's print the cost. No, system dot print ln the cost of coffee, right? It should come out to be the same. It should come out to be 90, right? Chocolate would be 20, simple coffee would be 50, 70, mocha would be 80, and almond would be 90, right? So let's check it. Oh my bad, coffee dot cost 90, right? And if I print the description, description, yeah, it's simple coffee, chocolate, mocha, chocolate. Why would it say simple coffee, chocolate? Thing. Yeah, almond. My bad. So it would say simple coffee, chocolate, mocha, almond, right? So it gave me the description, it gave me the price, and that's what the what a decorator pattern is. Now what I see is I think I can, like, I don't have to extend this. If ornament decorator already extends coffee, maybe somehow I can use a super method here. One, I can see that, and second, we can improve this pattern further by adding a builder to it. So instead of like doing this, we can have a fluent of API. Like for example, we can have a builder. Like I'm just thinking out loud right now. Builder. Oh, it's a coffee builder. Coffee builder, which is equal to. I will just say. I can just say coffee dot almond dot mocha dot chocolate. Kind of like we can have a builder pattern like this. But like that will do once we study about the builder pattern, right? Also we can have a factory pattern here to improve the the construction, right? Like for example, this does not look very clean right now. We can basically add a factory to it, and we can, via factory, we can create this. So most probably we will see the factory method in the next video. Okay, that's all.